Alright, so time for another video about Jeff Kempin's Telefunken console stereo. Been working on this for a while. I've put out a few videos of the various parts. It's been a while since I've made any videos. There's reasons for that, which I won't get into here. But needless to say, I have been working on this unit. As you can see, if you remember from the previous one, there was a pile of orange capacitors. Well, now you see orange capacitors all over the place. So yeah, they're all installed. All the ones I bought in that first batch I put in, and then I realized that I missed a few. I missed a couple on the board here, and also I was debating if I wanted to change out the caps on the volume knob here. The way they do these point-to-points, they put components anywhere they can, and there were 6 capacitors around this thing and a bunch of leads coming off of it, and I was kind of thinking maybe, oh, maybe I'll just leave those on there. And in retrospect, I probably should have, but unfortunately I didn't, and in the process I found that I've forgotten 2 of those as well, and then in the process of desoldering the old ones, I overheated one of the caps that I was not going to change. So these little guys is my bag of parts that I've removed. There's these little tiny caps, like picofarad values. Let me find the other one. There were 2 of them on the volume knob there, and these are particularly sensitive to temperature. And I was careful not to touch them with the soldering iron, but I got a little too close, I think. So here's one, and here's the other. And you can see how one is quite a bit smaller than the other one. Well, they were the same size until the soldering iron caused the plastic to shrink. These might be polyethylene, I'm not sure. You can see how tiny the leads are. That's partly to protect the plastic from overheating when you're soldering. Yeah, some of these early plastics from these days were very sensitive to heat, and so yeah, this one shrank, and I tested it, and it still tested okay, but I was like, oh, I don't want to leave it in there, so I bought a couple of silver mica ones that will last forever to replace those 2. But I didn't replace any of the other ones. Anywhere where you see these guys, I left them. Careful not to overheat them. Lesson learned. And then there were 2 more way back here. I'll give you a better view of it maybe if I remember. For the phono input, they're like right up against the tube on the top side of the chassis, and yeah, the wax was all melting out of one of them, and I was like, yeah, I gotta change those. So I had to drill out a bunch of rivets to get back there. But anyway, so all those are done. Everything is swapped. The volume knob is sort of just sitting in here temporarily. The brackets are still taken apart, just in case I need to fix anything, in case I mess something up. Basically what I want to do right now, which is why I'm rolling the video, because this could be very exciting or very sad. I'm going to apply some power to this thing, and I want to see if I have any short circuits. I've gone through the whole thing very carefully, added a lot of Teflon tubing to leads that were very close to touching things. Honestly, it's a miracle that these, when they make these things in the factory and then they get shipped around the world and jostled around, that they don't start shorting out. It's just, some of them are so close, I don't know. But anyway, it's better now. It should be pretty safe now, hopefully. So yeah, hopefully I don't have any of the caps in backwards, electrolytics or anything. They look fine, but triple checked all that stuff. I don't have a power supply yet. I haven't built that yet. That'll be the next thing if this goes well. But before I do that, I wanted to see where we were at. So what I what I've done is the main power transformer is still the way it was. The high voltage leads are taped off. I'm just going to use it to power the heaters on all the tubes. I've got that hooked up to the variac here, so let's fire that up. Hopefully nothing's wrong with that. I see the little lamps coming on, so that looks good. Just going to crank it up. Let's see any heaters on the tubes here. Yep, starting to glow. That looks good. Okay, and then to get the high voltage, I'm going to use this guy up here, this big old high voltage power supply. It's a Heathkit IP32. It's also HP made a similar one, or the same one. I think this is a copy of it. These are kind of common. You can find them. There's actually tubes inside, so you put it on standby and you heat up the tubes first. That way it's ready to go. You don't have to wait for it to heat up. One thing I like about it is that because it's using two big tubes to do the regulation, it's kind of immune to overloading. You can peg the needle, for a short period and catch things, and it won't blow anything up. It's pretty robust. Hopefully it has enough oomph to power this thing. I don't actually know. I only can put out 100 milliamps, so I don't I don't know if that's going to be enough. We'll find out. So as you can see, I have a ton of meters hooked up. That's how I like to do things when I'm working on high voltage stuff. Instead of probing around with a meter, I just got a bunch of these cheap Harbor Freight dollar meters and just hook them up to everything. They're not super accurate, but they free up my hands. I've also got my bench meter back here. You can't see it. That's looking at the output of this guy, because I don't really trust this. And then I've got this guy looking at the first leg, and the way these tube amps usually work is there's the power supply goes to the big tubes, and then there's a resistor to drop the voltage a bit, another capacitor for the next stage down, and then it goes down, 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 and the voltage drops at each step, so you get to the small signal tubes at the other end. So I just have some meters scattered throughout that chain of supplies, and so if all the tubes are drawing current the way they're supposed to, the voltage should drop down, and the schematic actually gives approximate voltages for what I should see, depending where I'm looking. So pull that up real quick. Alright, so yeah, let's trying to think if I'm forgetting anything before I apply voltage. Oh, I should probably turn it on. So normally this is how you turn it off, and then that powers the whole thing down, but I'm bypassing the power switch, so I should select something. I think that's tape, so that'll work. I should probably select those two for the equalization. Let's make sure the volume's all the way down. I don't know if this thing's going to oscillate or what. At this point, I'm just checking the power supply. Those are down. Alright, well, moment of truth. So I got this all the way down to 0. Switch it on. It always gives a little blip. Alright, so we'll apply like a real low voltage, and if there's a short circuit somewhere, this thing should just like spike. Or it should just be unusually high for whatever voltage. So let's see. Put about 25 volts, getting 10 milliamps. That's 5 milliamps. Voltages are all kind of where they should be. They drop a little bit. The power tubes for the amplifier are drawing. So these two are looking at the cathodes in the power section of the power amp, just to see if that tube is drawing current the way it's supposed to and is biasing itself and all that. Alright, let's turn it up a little more. Alright, it's 50 volts. So I got 50 on the plates, I got 45, 36, 37, 43. I must have these switched. Yeah. And yeah, we got about 15, 20 milliamps. It's pretty good. I don't see any smoke. a little higher in here. About 100 volts now. So we got 100 on the first stage, 86, 82, 66. Got about 2 volts across the cathodes of the tubes here. Grid to cathode voltage. .150 volts now. 130, 125, 96. Around 2 to 3 volts. Don't hear any creepy noises. Feel some of the heat coming off of it. Let's go up to 200 here. There, we got about 200. Still looks okay. Alright, let's just get it. My target voltage is 265. Alright, 265. So we got 265. The next step should be 220. I got 223. That's good. Next one down should be 190, and I've got, well, it could be 190 or 210, depending. It's 212, so that must be the 210. Then there's a 160, so I got 155, 156. That looks really good. So I got about almost 6 volts on one, 5.5 on the other. So yeah, one of these power tubes is weaker than the other, which I think we saw when we were testing it. So that's not expected, or that is expected. So let's see what the schematic says about that. Let's see. It says about 5 volts. Yeah, there should be 5 volts on the cathodes, and I got 5.4 and 6. So yeah, successful test. It's powered up. It's basically powered up right now. There's no power supply yet, but it's drawing 100 milliamps. I'm pushing the power supply here to its limit, pretty much. That's good to know, so I can actually test this more without having to build a supply. Though I still need to do that, but it's so much easier to bring it up nice and slow when you're trying to test it out. Just make sure I don't get zapped. All right, I hear some high-pitched squealing when I turn up the volume. Something's oscillating. That's not good. So I'll have to figure that out. The inputs are open. There's no I haven't shorted out the inputs. I'm seeing the magic eye. That's cool. Yeah, let me bring you in here. So there's all the meters. You can see how we're doing there. And yeah, so there you can see the volume knob right there, and all the stuff hanging off of it. The orange capacitors there. So yeah, when I go into one of the shortwave modes, look right here. You'll see the green. There, see it? That's a tuning. It squeezes when you have it tuned better. So let's see. That's the other shortwave. It's FM. That's AM and that's FM, I think. And then this is tape. Shuts off. So it seems to be working okay. Let's see if it squeals with AM. Yeah, it's squealing. no matter what I do. So something's wrong with the amplifier part, which is fine because that I know how to fix. I know how to diagnose that sort of problem. So we're back on tape mode here. So there's all the capacitors that are on that guy, and there's all those orange guys and those burgundy ones too. I replaced all those except for that gray one. That's still original. That was the right size, and I couldn't find that value in what I was at the place I was buying those from, so I just left it because it's fine. So yeah, let's shut this guy down here. Shut off the Variac. So yeah, I would call that a successful test, Jeff. As far as the power supplies go, I didn't do anything horribly bad to it, and neither did you. So I think we're okay in that regard. I got to figure out. I can hear. Maybe you can't hear it on the video, but there's a really high-pitched squealing when I turn the volume up. It's probably coming from the output transformer. There's no load on the output transformer. There's no speakers, and there's so it could be causing an oscillation, or maybe something is still wired incorrectly and it's causing an oscillation. So that'll be the next thing. I'll probably clean all these meters off of it, get it on the bench with a sound source and maybe a speaker hooked up to it. Probably not my nice speakers, but just a test speaker. And we'll see what it does with some load on it. Maybe it's figure out why it's oscillating. And once we do that, then yeah, kind of go from there. And then we just got to build the power supply and kind of button her back up. I'm gonna replace this cardboard that was here. It was all warped and it was causing the needle to rub on it when he went back and forth. So I'll fashion something for that. And yeah, fix the tuning capacitor because that was jamming up. I have no idea how the radio's working or if it's working, but so yep, that's where I'm at. Thanks for watching.